here's your promised video about Extrema. Okay, so like usual, I'm going to try to share my screen, and we'll talk about trying to talk our way through a PowerPoint, and that'll help the next class to go a little better, I think. Now, the Extrema just means extremes. All right, so you know when you're graphing something, the extremes are really important. Remember on your third test, the whole goal is you're going to be able to graph a function without your graphing calculators. So you're going to need to know where the extremes are, because those are going to be very important points for you. All right, so look what your book's going to, my definition is a little different than your book, but it's the same thing. When they say extrema, that's just their way of saying maximums and minimums. So instead of saying maximums and minimums, they can replace those two words with the one word of extrema. So when they tell you to find the extrema, they're asking you to find the maximums and the minimums. So look what it's going to tell you in your book. F of C, now that's a Y value. Okay, so maximums and minimums are Y values. Okay, so F of C is a minimum of your function on some interval I if F of C is less than or equal to every other Y value in that interval. Doesn't that make sense? This Y value is a minimum if this Y value is smaller or equal to all the other Y values. All right. This Y value, F of C, is a maximum of that function on some interval if that Y value, F of C, is bigger or equal to every other Y value in the interval. Doesn't that make sense? All right, now I kind of labeled these like A, B, C, D, E, F, and then went back and labeled that one G. So do you understand that this point right here, A, would be really important? It's a high. So we understand that's the maximum, okay? Now, it's not the biggest one in the whole graph, so that's what it means by it's a minimum on an interval I. So, I mean, you know, from like here to here, you know, it's the biggest. Does that make sense? So on some interval, it's the biggest. All right, so it's going to be called a relative maximum, because in some space in this little interval, it is a maximum. Do you see that this would be a relative minimum? It's not the complete lowest point on the graph, but in this interval, it's the lowest point on the graph. So these are our extremes, okay? So does it make sense to you that your maximums, your relative maximums would be A and C and E? They're the highs of the graph. All right, so those would be very important points for everybody to graph if you had to graph this particular function. Does it make sense to you that B and D and F and even G are lows on the graph? They're minimums. All right, now actually, let me rephrase that. That's not technically true, okay? A, C, and E's are maximums, relative maximums, and B and D are relative minimums. G and F are endpoints, so the graph's getting chopped off. So sometimes an endpoint is going to be a low, so I've got to be careful, okay? Now, how do you find these extremes? How do you find these highs and these lows? Well, let's go look at, they're going to tell us how to find them. The first thing we're going to have to do is find something called critical numbers. Now, what's a critical number? Critical numbers are X values. So you need to write in your notes that critical numbers are X values. Okay? And maximums and minimums are Y values. Okay? So critical numbers are X values. We'll talk about in a minute. Maximums and minimums are Y values. So go back and look at this for a second. Let me show you something that you probably didn't notice, but you're going to notice now. Okay, let me clear these, what I had before. Now, do you see that if I went and I drew tangents at all the highs and lows, so if I drew a tangent line right there, I drew a tangent line right there at C, and I drew a tangent line right there at E, and I drew a tangent line right there at D. Do you see that at those places, they're horizontal tangents? So what's the slope of those blue horizontal tangents? Wouldn't those slopes be 0? Well, what's the same thing as the slope of a tangent? Isn't that a derivative? So do you understand that at A, B, C, D, and E, at all of those points, the derivative right there would equal 0. So that's going to be part of being a critical value, where the derivative is 0. We're probably going to have highs and lows. Now, the other thing that's true is this. Suppose the graph had been a sharp point, like maybe absolute value. Now, remember we talked about before, you don't have derivatives at sharp points, but that would be a low. Or up here, that would be a high. So I would need to know what this point is right here. That's going to be real important. Okay? So it's critical that I know what this number is. Well, the derivative there, remember, doesn't exist. Okay? So that's why when we get over here to critical numbers are where maximums and minimums occur. They're not the max and mins, they're where they occur. So they're where the derivative is either going to equal 0 or where the derivative is undefined. So if I say find any critical numbers of something like y equals x squared, you simply take the derivative and you find out, well, when does that derivative equal 0 and when is that derivative undefined? Well, when does 2x equal 0? Well, if I divide both sides by 2, it's going to be when x is 0. So here's a critical number. Now, when is 2x undefined? Never. So I don't get an empty set. I don't get any critical numbers here. So sometimes you don't get critical numbers. All right, and think about it. If you went and drew the graph of y equals x squared, aren't you going to get that parent parabola, that general parabola? And isn't this going to be the lowest point? Isn't that going to be a minimum? And what's the x coordinate right there? 0. Okay. Now look at another one. This one's a little different because this one's a little more algebra involved. It said find any critical numbers of this function, 2x minus 3x to the 2/3. A little hard to read. So I took the derivative. Well, the derivative of 2x is 2 minus, we don't touch numbers in front. Now x to the 2/3, that 2/3 comes down. My expression stays the same. I decrease my exponent by 1. So 2/3 minus 1 is going to give me a negative 1/3. And then the derivative of that inside of x is just 1. So I get 2 minus, now remember this 3 and that 3 would divide out. So I get a 2x to the negative 1/3. That negative is a little hard to see. So let me make sure we understand. That's a negative 1/3. Now we don't like negative exponents, so I pulled it to the bottom. So 2 minus 2 over x to the 1/3. Now that's cleaned up enough for me, but I know what I'm looking for. I'm looking for where the derivative is undefined or 0. So I think a different form would be better for me here. So I'm going to go to a different form. I'm going to change that 1/3 back to the cube root of x. All right, because cube root, I think better in roots than I think in fractional powers. And then I made a single fraction out of it. So you understand that's 2 over 1. Okay. So 2 divided by 1. So my common denominator is going to be the cube root of x. Well, what did you multiply 1 by to get the cube root of x? The cube root of x. So you've got to take your old numerator 2 and multiply by the cube root of x. Well, this denominator didn't change, so that numerator won't change. Okay. So this right here is just 2 the cube root of x minus 2 all over the cube root of x. Now it looks nasty, but look why this form is better. I need to know when that derivative equals 0, and I need to know when that derivative is undefined. Now, isn't that a fraction? So when does a fraction equal 0? A fraction equals 0 when the numerator is 0 and the denominator isn't. Okay? So all I've got to worry about is the top. So I went and set the numerator equal to 0. All right, I'm trying to isolate this x over here. So I got rid of that minus 2 by adding 2 to both sides. Then I need to get rid of this 2. So if I divide this by 2, I got to divide that by 2. So when you divide that by 2, that goes out and leaves you the cube root of x. And then when you divide 2 by 2, you get 1. Now I don't want the cube root of 2. The cube root of x, I want x. So I'm going to have to cube both sides. So I'm going to cube that side. Then I'm going to come over here. Sad with that. And then I'm going to cube this side. So the cube root of x cubed is just x, and 1 cubed is just 1. So there's one critical number. Okay. Now, I need to know, is that thing ever undefined? Is this derivative ever undefined? Well, again, it's a fraction. When is a fraction undefined? Isn't a fraction undefined when the bottom is 0? All right, so I just took the cube root of x and set it equal to 0. So I cubed this side and got x and cubed that side and got 0. So I've got two critical values, 1 and 0. So I'm going to have a max or a min. I don't know if they're going to have maxes or going to have mins. We'll talk about that in class. Okay, it's easy to find, but they're either going to be maximums or minimums. I don't know which one yet. Okay, but notice the critical values are the x numbers that are going to occur. All right, so it's not that 0 is a max or min or 1 is a max or min. It's at when x is 0, the y part of that point is going to be a max or min. When x is 1, the y part of that point is going to be a max or min. Okay, so critical values are the x coordinates where the maxes and mins occur. All right, so look what it says. If they ask you to find extrema, find maximums and minimums, your first step is you find your critical numbers. So remember, how do we do that? We find the derivative and set it equal to 0 and set it equal to undefined. Okay, we substitute those critical values, those x values, into your original function. Remember I said it was the y coordinates. All right, those y values are relative maximums and minimums. All right, they're lows and highs on the graph. Now, sometimes they're going to chop the graph off. If they chop the graph off, you also need to evaluate the y values at those x values. So plug those endpoints into your original function. Then just look at all the y values that you have. Now, they talk about the absolute maximum. That's the highest of the highs. And the absolute minimum. That's the lowest of the lows. So you would look at all of your y values from steps 3 and 4. And the biggest one is your absolute maximum, and the smallest one's your absolute minimum. Okay, let's go do one, and then you can see what I'm talking about. So you might go back here and freeze that and copy that down in your notes. Okay, and do that before you move to the next slide, so you can look at your steps because I've got them numbered. Okay, all right, hopefully you're back. Look what it says. It says find the absolute extrema, so the highest of the highs and the lowest of the lows of this cubic function between x equals 0 and x equals 3. So it's an S curve. Remember, cubes are S. I'm chopping the graph off. So step 1 said to find your critical values. So we've got to take the derivative. All right, so we take the derivative. So that's 6x squared minus 6. Now I've got to set that equal to 0 in a minute, so it really needs to be factored. All right, so you might go back even and put factor if necessary in your notes. All right, well, when I factor a 6 out, I've got the difference of perfect squares, so I've got to fully factor. It's got to be fully factored. All right, so when is that equal to 0? When is this thing equal to 0? What is when each is 6 ever going to be 0? Can x minus 1 be 0? Yeah, when is x minus 1 0? When x is 1. Well, what if x plus 1 is 0? Well, x plus 1 is 0 when x is negative 1. So I could set each one of these things equal to 0 and solve it, and I get two critical numbers. All right, is that derivative ever going to be undefined? Is 6 times x minus 1 times x plus 1 ever going to be undefined? No. So I've only got two critical values, 1 and negative 1, and notice they're x numbers. Now, step 2 tells you to substitute those x values back into your original equation. So I'm going to plug a 1 in there. So 1 cubed is 1, 2 times 1 is 2. All right, minus, and of course, 6 times 1 is 6. And then 2 minus 6 gives me a negative 4. All right, then I plug this one in there. I plug a negative 1 up here. So I'm going to cube that negative 1. So when you cube a negative 1, you get a negative 1. And negative 1 times 2 is a negative 2. Minus 6 times that negative 1. Well, minus a negative is plus. So now I get a positive 4. So that's what it means on basically step 2 about substituting those numbers back into your, about substituting them in. And then step 3 says those y values are relative maximums and minimums. Now, here's what seems easy, but I don't want you to, we'll talk about this more in class. Just because this number is smaller than that number doesn't mean necessarily that it's a relative minimum. Let me show you what I mean. Now, that's not true on this graph, but I want you to notice something. Do you see that this value, this y value, would be bigger than this y value? It's higher. Yet this one's a max on an interval and that one's a min on an interval. So be real careful. We're going to learn how to label which ones are maximums and minimums, okay? Then all I know is that they are maximums or minimums. I don't know which yet. All right, then step 4 says if you've got endpoints, substitute those in. So I substitute 0 in there and get 0, and I substitute 3 in there, and when I do, I get 36. All right. So now step 5, the last step says look at all the y values. We'll see that's a y value, that's a y value, that's my relative maximums, that's my relative extrema, and then these are my endpoints. So look at all my y values. The biggest one's my absolute maximum. So the biggest one, the biggest y value is 36. So my absolute maximum is 36. See, it's a y value. Okay. My smallest one, well, the smallest one out of that's my -4. So that's my absolute minimum. Now, because we're going to be graphing at the end, sometimes you'll see me phrase it like this. I'm going to say the absolute maximum occurs at the point 336. Because when we're graphing, we're going to need the x and the y coordinate. But if you tell me the absolute max is this point, I'm going to count it wrong. Okay? The max is a y value, but the max occurs at that point. So that's the 3 is the critical value and the 36 is the maximum. So you can say the absolute minimum is -4. See, it's a y value. Or you can say the absolute minimum occurs at the point 1, -4. So 1's the critical value, -4 is the minimum. All right. But if you say the absolute minimum is that point, I'm going to count it wrong. So maxes and mins occur at points. And the x coordinate is your critical value and the y coordinate is your maximum or your minimum. Okay. So hopefully that will make that go a little bit better. And we will go over it when I see you in class. Okay. We'll kind of pick it up from there. So if you didn't take notes, you need to reverse it, go back and take the notes because you're going to need those examples in your notes.